Hello everyone, welcome back to my math channel of MathFab. In this video, I will answer you question number 4 from Cambridge AS and A-level exam for Pure Math 1. This exam is taken in October-November session year 2024. Paper reference code is 9709/11. Show that the curve with equation x squared minus 3xy minus 40 equals to 0 and the line with equation 3x plus y plus k equals to 0 meet for all values of constant k. When a quadratic and line meet each other, let me tell you a quick idea. There are three possibilities. This line can intersect this curve at 2 points. These are called the real solutions, two real solutions in that case. Okay. In this case, discriminant is always greater than 0. This is the case 1. When a quadratic equation is given, quadratic is always U-shaped or N-shaped. It depends on the coefficient of x square. And this is the linear. Linear is a straight line. There are three cases arise here. First case, it can intersect the curve at 2 points. Now the second case, it can intersect the curve at 1 point only, like this. It intersecting the curve at 1 point only. In that case, discriminant is equals to 0. And we have one repeated. Actually, in that case, we have one repeated root. Okay, this is the second case. And third case, this is not intersecting, it is passing like this. So we can write here no real roots in that case. And in this case, discriminant is always less than 0. And what is the discriminant? If you remember the quadratic formula, this is not the part of the solution. It is just only let you understand about these type of questions. If you remember the quadratic formula, that is minus b square plus minus square root of b square minus 4ac divided by 2a. Okay. Actually, this one is called a discriminant. This one, b square minus under the square root. If this value is greater than 0, we will get two real roots. If this is equals to 0, we get only one repeated root. And if it is less than, like negative answer for the part that is under the square root, we will get no real roots. We will get imaginary roots. Okay. So first of all, we will solve these two equations together. Let me write the equation of the curve, that is x squared minus 3xy minus 40 equals to 0. And we'll write this equation in terms of y, that will be equals to minus 3x minus k. We'll move these two values to the right side to get the value of y. So substitute this value here. So it will be x squared minus 3x into y, that is minus 3x minus k minus 40 equals to 0. Expand the bracket, it will be x squared minus this minus and that minus makes it plus, so it will be 9x squared, and then minus 3x multiply by minus k, we get the answer as positive 3kx minus 40 equals to 0. 9 and 1, these two are like terms, so you can solve them together. It will be 10x squared plus 3kx minus 40 equals to 0. From here, you can find the discriminant. Discriminant formula is b squared minus 4ac. As I told you earlier, this is called the discriminant. So b is here, in quadratic, the coefficient of x squared is a, coefficient of x is b, and the constant term is c. Substitute the values. B is 3k squared, 3k whole square, minus 4 into 10 into minus 40. And we'll get the result as 9k squared, and plus it will be 1600. So discriminant is 9k squared plus 1600. If you notice that this is already positive, we know that, and the square is always positive. Okay, k square is always greater than 0. It is positive, it is always positive. Therefore we can write as this one, 9k squared plus 1600 is always greater than 0. for all values of, for all real values of k. You understand? This shows that this result shows that because we got the result discriminant greater than 0, it means we will have a real solutions in that case. This was our purpose actually. Show that the curve, this one, and line with the equation this one meet for all values of constant k. Hence you can hence prove the result. Hence you can write the same statement. The curve and line meet for all values of k. Yeah, actually at the end you have to write this, what you need to prove. We already proved that discriminant is greater than 0. Greater than 0 means the curve and line will meet, for sure it will meet at two different points. Hence the curve and line meet each other for all real values of k. Hence proved. So we proved the result. Hopefully you understand it. Still, if you have a doubt or you want to write any comment about this question, please write in the comment box. Thank you.